What is going on, everybody? Welcome back to another video, Cup of Kodo 1. Today, see if I can get my cursor guy over here. Today, we are going to be beginning and rocking out good old... Oh, why are you not doing anything? Machine learning. So many of you have asked about this. When are we going to start machine learning? I'm starting it, well, now, today. We're going to be doing this from more of a data science standpoint. And then the more we do, the further we're going to work along. And we're going to get more into deep learning. And then we're going to bring into artificial intelligence. Even though I just want to kind of say off the bat, for me, the way that I mentally have this stuff categorized, I have AI... Forgive my incredible drawing and handwriting here. ML. And then I have deep learning. So this is kind of where it all sits. So deep learning is just different kind of techniques, some new algorithms, more techniques that we can utilize within machine learning. And then it's the deep learning and machine learning techniques that we can utilize. Those are not boobs. I'm just showing you how we use deep learning into ML and then into AI. But AI is a separate beast all into itself, at least in my mind, how I have it separated. So let me clear out that whole layer and let's rock and roll. So I'll keep it that way for now. So I just want to quickly state some premises. This video is going to be about the beginning of ML. We don't do a lot of theory. I'm more about practical, as you can see from my videos. I want code, and I want more code. And then I want to see how the hell it's working. But we still have to understand some premises, and there is some theory within ML, but this is not going to be math heavy. You don't need to know the math in order to utilize and employ machine learning or deep learning or even artificial intelligence. It helps later on down the road, but for 99% of the work you're going to do and want to do, you don't need to know the math. So don't be put off by that. So what is machine learning? Well, we are going to think of machine learning as essentially training computers on how to learn patterns from data. And this is why you can't go by my handwriting, you have to listen. But we're training a computer to learn patterns from data, and that's the biggest piece there, is learning patterns from data. But the main thing is that these patterns may not be programmed. So you cannot program the patterns in. That defeats the entire purpose. Now that's just called code if you were to do that. And essentially what we're doing is we're training the computer on how to learn patterns from data, and we want it to make predictions based off of that data, or statistically valid. Holy crap, this is getting bad, huh? Statistically valid decisions. Let's clear it out. So, machine learning, we are simply trying to train the computer on how to learn patterns from data. So we're giving it all of this data, however that spreadsheet's going to be. We're taking that data, we're feeding it through our ML model, and that's what we're going to be building and learning. And what it's going to do is, without being explicitly programmed, this ML model is essentially going to be our algos after we've cleaned data and wrangled it and modified it and hyperparameter string, all that fun stuff, running that algorithm through it so that it can find the patterns. And then it's going to give us either a prediction or a statistically valid decision. Pretty much saying, here's your input, I ran it through this algo, and based on that, here's your output you're going to get. And then half of like machine learning, all that stuff, we're training it in the beginning. The training part is we're saying, here's your input, here's your desired output. Now you figure out how to go from here to here. You do all that learning in between. And you tell me how to go from here to here. I'm not going to program for you how to go from the input to the output. You're going to tell me. So if I give you a picture of a dog, I want you to give me the label of dog on the output. How you go from here to here, That's all the ML, DL learning that we're going to be utilizing. That's the fun stuff of how you can take your inputs and how the hell you get to the proper label. And then we're going to be training it, because if it comes out, we give it a dog, and it instead comes out and gives me a classification of a cat or a squirrel, well, then that was a fail. That was bad, obviously. So this is the premise of where we're going to be going with ML. So we're feeding data to the code. It's going to find the patterns on the training data, and it's going to apply the learn pattern model to new data. So once we get the algo that we're going to use, then we can utilize that. Oh, that was big. Once we have the algorithm we're going to use, then we can utilize it on new unseen data. That's going to be our testing data. We're going to train it, test it, and then we can apply it to new data parameters that we see fit. So I just want to quickly start off by saying there are two different models of all of this stuff: ML, DL, and AI. So you're going to have academic and you're going to have practical. Academic has a huge focus on the math and the theory of it all. And this is for writing algorithms from scratch. That's a primary purpose there. This is absolutely, academic learning is needed for the research. For if you want to go state-of-the-art algorithms, you absolutely have to have academic. And this is going to be your colleges, universities, master's degrees, PhDs, and even though there's not many for ML. I think Carnegie Mellon has a machine learning undergrad degree you can get. But this is for academic machine learning. You need to write highly optimized algorithms from scratch. Then you got to know your math and your theory if you got to do highly optimized algos, 1,000,000%. However, this academic does not apply for maybe, I'm going to say 97.3% of us, which means you don't need the math or theory to do the majority of the crap we're going to be doing. It's only when you get big, bad, and bold, and then you got to start making your own algorithms. But by then, you're a very, 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 very wealthy and famous coder, and you don't have to worry about that. So practical machine learning, this is practical machine learning. I'm actually going to give this its own page because it's that important. So practical machine learning. This is simply finding the best tool for the job. That's going to be like algorithm selection, model selection, and so forth. What's the best tool for the job? What am I being asked to do? What am I being asked to accomplish? What's the best tool to get there? That's practical machine learning. We always want to use intuition over theory. It does not make a goddamn difference what the theory is going to be. If you don't understand, if you don't have an intuition for the model that you're using, if you don't have an intuition for k-fold cross-validation or for bias variance trade-off, if you don't have an intuition for that, then the theory is not going to mean anything and you can't move forward. So in order to make this decision, you have to have this about everything that you're going to be learning in machine learning. We want to solve real world problems, not third world, not first world, but real world problems. And we want to do that in real time as well. We're good at time forecasting as well, something that most ML programs are never even going to delve on. And we want to essentially extract from it real value. We want to get real value by solving real world problems. To understand the different flowers and the different species of flowers, you get it, you can understand it, but you're not going to develop much intuition. You'll get more of the theory, but you're not going to get much intuition, and you're not solving a real world problem unless, of course, you are a botanist trying to decipher between the species of different flowers that you have, say, you're doing computer vision of. That actually does have a play in agriculture. Computer vision is actually very big in agriculture. And practical machine learning, I mean, it's practical and productive. So either the projects that I like to do, they got to be the best tool for the job. And you're not going. When I say the best, it doesn't mean we're going to waste our time trying to find the best. First and foremost, we want to get something that works, and then we get fancy. First, you got to make something that's going to work. So, and that leads me to, this is going to require not only its own slide, but its own color. I guess I should memorize some of these color pieces, huh? So, here's a little formula you have to memorize. Fast and efficient. Fast and efficient results is 10 times better than the best answer that takes 10 times longer to find. This is what it leads me into. So fast and efficient results are 10 times better than finding the best answer. Because the best answer, you can argue it's the best, but it might take you 10 times longer to find it. So by the time you found the best answer, I've been developing fast and efficient results over and over and over and over and over and over again, and modifying that and getting it over and over and over, and then bringing this into deep learning, bringing this into AI, and I'm getting better and better. Meanwhile, you produced one, and you're going to say, oh, my best answer is better than this, it's better than this. Sure, but look what I've produced. Fast and efficient results. Actually, products to market, or actually development of code. That's getting better and better with each evolution and each different version of the code. So 1,000,000%. You've heard, best viable product. When things come to market, whenever we have beta, it's never the best. It is never the best answer. But it is fast, efficient, and it does have fast, efficient results, which is, of course, 10 times better than having the best answer. So always, always, always focused on first getting something done. Then we can get fancy with it. But first and foremost, get it done. So, algorithms are commodities. I want you to think of algorithms, and anytime I say algo or algorithms, as simply a tool. It's a mathematical tool that we're going to be using. It's code, but it's just a tool that we're going to be using. It's a useful and valuable thing. That's it. The algorithm is going to be the tool that we're going to be using. My personal focus is about mastering the ability to apply the existing algorithms to get incredible results. So there are thousands of current algorithms that are in computer science world. Thousands of them. To me, that just means I have 1,000 tools. Now, I'm not using 1,000, don't get me wrong, but that means I just have tools. That's it. And how can I use those tools to get incredible results? How can I apply them if I have different problems? Whatever those problems are, I have a toolbox. And I'm simply just taking that toolbox and I'm applying it to say what's going to give me the best results. That's it. That's all an algorithm is. It's a process. It's a step-by-step. A recipe. If you're baking cookies, I'm going to get myself hungry. If you're baking cookies, that's an algorithm. You followed an algorithm. It's a procedure. It's a step-by-step. It's a method. An algorithm is simply just a tool. We're utilizing tools. We're utilizing steps. And it's a step-by-step. So if you have a recipe and you have to follow all 5 of these steps for your recipe. Did I lose it? There we go. If you have to follow all 5 of these steps in your recipe, well, I can just call this an algorithm now. Because what it's doing, it's encompassing all 5 of those steps. I don't have to hard code each of these individual steps as I'm doing it. All I have to do is call that algo, and then I can put my code in place. And then that algorithm, these 5 steps are going to work on whatever I'm putting in there. So the algorithm is just a tool. Never get caught up, never get scared. It's simply just a tool that we're going to be using on the data that we're going to be messing with. So what do we need? What I want you to do, of course, most of us already have Pycharm if you've been following my videos. But what you're going to need is, let me bring this over here. I, of course, tell everybody just to go with Anaconda. And I want you to get Python 3 version of that. I'm going to be using, I think I'm using 3.6 as of right now. But I want you have to have Anaconda for Python 3. I'm going to be using Pycharm. Absolutely. And I'm going to show you in a second how I use certain libraries in Pycharm. The libraries we're going to be messing with a lot is the NumPy library, Pandas library. Can I make this? I mean, I'm sure I can. Pandas library we're going to be using. Oh, that is horrible. I got to find a better way to do the handwriting piece. Tool. I'll figure that out later. Matplotlib, and I'm going to show you how I installed these in just a second with Pycharm. We're going to be using Seaborn as well. It's going to give us a lot of our fun graphs, and you're going to be learning sklearn very well. So NumPy is our numerical computing piece. NumPy is our numerical computing library that we're going to be using. This is extraordinarily powerful. Pandas is going to be our data analysis and exploration library that we're going to be using. Matplotlib is how we're going to plot the different tools that we want to visualize the work that we're actually doing. Seaborn is just a much prettier and more flexible version than Matplotlib in terms of graphic analysis. And sklearn, this is the muscle of a lot of machine learning. I mean, you want to talk about libraries and algorithms. Scikit-learn, it has a massive amount of libraries that we're going to be utilizing. So what I want to do now to end this video off, I'm just going to show you how I install all of these within Pycharm. So let me bring Pycharm up. That should be totally sufficient. And I want to tell you exactly, let me shut this off really quick. So what are we doing here? In Pycharm, you can open up any Python file. I just named this one ML_1 because I want to kind of keep things consistent. First and foremost, you're going to import NumPy as NP. Now, if you don't have, and I want to show you how you can find the version of something. So we're going to call NumPy. I'm going to put this there. And I actually want to put a couple spaces so that it's lined up properly when we see everything later. I'm going to put a space. I'm going to put np dot __ version. If I can get the backspace properly. My goodness, my spelling is horrendous. __. And then, of course, we had to close off our print function. So you can see how in Pycharm it made my import blue and my as blue because I have the NumPy library. And I'm just going to run this right now so you can see. And it tells me NumPy version 1.12.1. So let's say you need to, if you don't have the library, what you can do is under File, under Settings, you want to be under Project Interpreter. And in Project Interpreter, you can see that my interpreter is 3.6.1. I'm calling for the Anaconda 3 Python for the interpreter. But you would go to the plus sign over here. And if you don't have the plus sign, wait, because on the bottom of your Pycharm, it tells you it's updating skeletons. But I would go to my plus sign here, and then I would type in NumPy. And it's going to highlight NumPy already for me, but I'd find NumPy, the array processing for numbers, strings, records, and objects. That is correct. You can see that's version 1.13.3 already here. I don't need it. I'm fine with the 12. And you would just hit Install Package. When you hit the Install Package, it's going to be doing its thinking, and I can't show you this. Can I show you this? No. On the bottom, it's going to say Installing Package NumPy in the bottom of your Pycharm, and it's going to give you a kind of a gauge. Looks like a horizontal barbershop sideways gauge that it's installing it right now as we speak. And then you can see on the bottom it says package NumPy installed successfully. So I can close that out. I can hit OK, and I can bring this up so you can see that see how down here now it's querying the skeleton generator, because now I added a new library, essentially an updated library. So now I should have 13. Let's see if it worked. Just got to wait for the libraries to be done. Package install, blah, blah, blah. Let me run it now. Good, 112. So I didn't rectify the skeleton yet. So I can stick with 112. So what you want, excuse me, we want to make sure you have NumPy. You're going to make sure you have pandas. And we're always going to be using that. The notation technically is as PD. We're going to be using, like I said, matplotlib. And we can call it as MPL. We're also going to be using Seaborn, and that's typically going to be called SNS, and our big boy, sklearn. And after if you don't know if you have them, so I'm going to change this, of course, to pandas. Bring it back just so it is aligned. And of course that is PD. So I want to make sure I'm calling the appropriate piece. Matplotlib, and we call this MPL. Just so it's lined up pretty. And then we had Seaborn. That's going to be our nicer graphing. And that's going to be SNS. You can see how they're changing colors up above as I do this because I already have them. sklearn, you're going to really come to love sklearn. And I don't need you. As you do, if you ever go through documentation sklearn, you might find it as scikit-learn, but not very different. So let us run that now, and let's see if I'm going to get all of the appropriate versions, or rather versions that I'm using, so you can see what I'm working with. So it tells me that I have NumPy, Pandas, Matplotlib, Seaborn, sklearn, and these are the versions that I'm going to be messing with as we do this ML course that I'm going to be running through. So NumPy 1.12.1, Pandas 0.20.1, Matplotlib 2.0.3, Seaborn 0.7.1, sklearn 0.18.1, and again, this is on Python 3, utilizing through Anaconda. So with that being said, I'm going to end this today. I just want to show you what libraries we're going to be using, give you a basic, very utter general idea of machine learning, and breaking up the difference between academic and practical. We're not messing with academic. We're messing only with practical. The math and the theory can be waited for later. It's more important you understand the tools and the intuition of those tools. And then, of course, that you can beat into your brain that fast and efficient results are always going to be 10 times better than getting the best answer that could take you 10 times longer to find. We want to get betas. We want to get first viable product. We want to get something that actually works. And then we can go back and make things faster, make them a little more general, modify algorithms, improve the results. And sometimes very, very, very small tweaks is all that's required for massive, massive change. All right, guys, with that being said, excellent time today. And I will see you in the next video, which will be doing more machine learning. Next video, I can tell you now, we're going to be getting into understanding the problem that we're doing with machine learning, talking about supervised, unsupervised learning, and then something called model complexity. Model complexity is a very general way to get intuition over machine learning in general. All right, guys, take it easy, and I will see you in the next video.